Okay, well, here we are at the end. So let's proceed without haste. So I have two boxes. I'm not going to write everything. I have two boxes, box one, box two. I select box one with probability 1/3, box two with probability 2/3. And I want to find the probability that if I draw two balls from the boxes, the second one is red, given that the first one is red. Okay, so let Ri equal ith ball drawn is red. Okay, and let Bi ith box selected. Okay, so how do we do this? So we'll just unroll the definition here. So we just write P R1 R2 over P R1. And then we recognize that we need to condition on which box we select. So pretty straightforward. This is just P R1 R2. And I am skipping steps here because we did several examples at this point. B1. Okay, it's the probability that the numerator is the probability that we picked R1 and R2, and that is this. Because these two events, their union makes up the probability. Their union is R1, R2, and they're mutually exclusive, so I can add them. So I did those, I skipped that step where I wrote the union. And similarly, the bottom can be written like this. I'm getting excited because this is the last video. Okay, so now how do we compute those? Well, let's do the top one, P R1 R2 B1. This is just equal to probability R2 given R1 B1 times the probability R1 B1. But that's probability R2 given R1 B1, probability R1 given B1, probability B1. Okay, that's unrolling it all for you. So, and then these each we can do. Probability B1, 1/3. Probability R1 given B1, 1/4. Probability R2 given R1, 0. So this is 0. Okay, what about the next one? P R1 R2 given B2. This is not 0. So similarly, if I skip even that step now, it's R2 given R1 B2, PR1 given B2, PB2. And this is equal to, what do you think? Well, same thing, right? Okay, so this is 2/3. R1 given B2 is 4/9. And R2 would be, this would be 3/8. Okay. And it's not hard to see from here what the denominator is, right? This is the denominator. Here's PR1, B1. So I have those already. So we're done. So we have P R2 given R1 is equal to, this is the numerator, 3/8 times 4/9 times 2/3. And the denominator gives me 1/4, 1/3, plus 4/9, 2/3. Let's actually compute this within our heads. Here we have 216 in the denominator, so let's clear the fractions, multiply by 216 on the top and bottom. I get 24 on the top. On the bottom, I have 216 and 12 here. So when I divide 216 by 12, I get 18. And when I divide 216 by 27, I get 8, right? Yeah, 8. And here's another 8 up here. So I have plus 64. So this is equal to, should take out at least a 2 here, right? So this is 74, 82, 41, 12 over 41. The probability the second one is red given the first one is red is 12 over 41, if you could believe that. All right. Let me set up the other direction here, even though I don't think I'll finish it, but just to set it up. So suppose I want to do this one now, P R1 given R2. Well, this looks pretty similar. The numerator's the same. The numerator's the same. The denominator's a little harder though, because R2 can come about, well, actually it can't come about in the first way. So maybe we can do it. So how can R2 cannot come about from box 1. If it could, there would be 4 different ways, right? So what I was going to do is I'll write it out. We'll say P R1 and R2 are done as above. But what about PR2? Well, this is P R1, R2, B1 plus P. Oh, no, it can come about all these ways, right? P B1, I'm sorry, yellow 1, R2, B1 plus P R1, R2, B2 plus P yellow 1, R2, B2. Okay, it can come about each of these 4 ways. So I have to do each of these. I know this one's 0, but this one's not 0, right? And this one is not 0. This one we did. So this one we did. This one we did. So this is 0. So this is equal to 0. So I won't write it. 0 plus P Y1 R2 B1 plus this one we did. So this was 3/8, 4/9, 2/3 plus P Y1 R2 B2. And these can be done just like this one can be done, right? By conditioning on each of those 2 separate, on each of those intersections of 3 things. So if I'm going to write it out, I need to find a piece of paper. I'm almost out of paper, which is a sign that I should stop. So let me continue though, just to see. I'll go another minute. So let's just try to do one of these. What's PY1 R2 B1? The way we want to do this is the natural way to do it. This is P R2 given Y1 B1 times P Y1 given B1 times P B1. And all these things we can compute, right? I can go back to the boxes here and see that I can compute them all, right? So what's P R2? Well, let's do this one. PB1 is 1/3. PY1 given B1, that's 3/4. And P R2 given Y1 B1, that should be 1/3 now, right? 1/3. Similarly, PY1 R2 B2, this is equal to, oh my God, this is equal to what? P 2/3. Now what's the probability the first one's yellow in the second box? It's 5/9. I'm not going to pull that page down. And the probability the second one's red. Well, now this should be a half, right? Because I have 4 of each. So now we have it, right? So P, so let's see, so now we have it. So P, well, it's still a bunch of stuff to write, but I think we can do it. It is just all this stuff. So P R1 R2 is that. So I think we get P R1. How much time's left? Do you even care at this point? You have everything you need here, right? So you have, this is the expression, PR1 given R2. PR1, R2, this is the numerator of the previous part. So this is this. This is the numerator. And for the denominator, we have this plus this plus this. And where these are given here. And down here. Okay, well, that basically shows you what to do. I wonder how many people are still watching this, but that concludes chapter 3. We start random variables next time. Thanks for watching.